Oh man, you guys, we are now tackling our final isosceles trapezoid problem of the day. Now, we will be talking about another nifty theorem associated with mid-segments in trapezoids, but for now, this will be our final example problem on isosceles trapezoid, which I know this figure is an isosceles trapezoid, not by the way it's marked because my legs are not congruent. Okay, but it does say in the problem that I can assume the figure is an isosceles trapezoid. Yay! So I can mark these two sides as congruent because the legs are congruent in an isosceles trapezoid. Okay, so the problem says j to the L is 5z plus 3, which I'm going to label that over here. So JL is 5z plus 3. And k to the m, the other diagonal, is 9z minus 12, which I'm going to label over here. So 9z minus 12. And guys, remember my z's, I like to put dashes through them so they don't look like 2's, because my 2's sometimes start turning into z's, so be careful. Alright, so it says to find z, find JL, and km. So I have something about the diagonals of an isosceles trapezoid. So let's see if there's a nifty property that we can use about isosceles trapezoids. We'll see what we can find. So anything about the diagonals. Do you guys see it? In an isosceles trapezoid, the diagonals are congruent. So that means that km is going to be congruent to JL. Holy hot dog. Alright, so we know that Km is congruent to JL. Alright, which means that their lengths are equal. So Km will equal JL. And sorry, that should say JL. The demon cat totally got Miss Long right now. What is your problem, Miss Long? Jeez. So much whiteout. Always have whiteout if you ever do a math problem in ink. Okay, so JL, there we go. Okay, so all I can do now is substitute in the values where they go to find z, which that's going to help me find JL and KM, so get excited. Okay, so if KM equals JL, I can set these bad boys right here equal to each other. Let's do this thing. So 9z minus 12 will equal 5z plus 3. Alright, let's do this thing, which I'm going to reserve some space to find Km and JL at the end. Okay, so I know that these two are congruent. That is why I set them equal to each other. So this diagonal is congruent to that diagonal, the whole thing. Not just like this piece, the whole diagonal. Alright, let's do this thing. Okay, so first of all, I need to bring my z's together because they're besties and they miss each other. They want to be reunited. So how do I bring my 5z to the 9z? Well, since it's a positive 5z, the way we move it to the other side is by subtracting it on both sides. Which 5z minus 5z cancels and turns to 0, and 9z minus 5z gives me 4z. So I'm left with 4z minus drop down that negative 12 and drop down my 3, which is positive 3. Sorry, that's just a 3. Just go with it. Okay, so that's 3. Alright, so now that my z's have joined together, I need to move everything to the other side. So how do I bring negative 12 to the other side? I do, in fact, add it. So I'm going to add that thing on both sides, which negative 12 plus 12 cancels and turns to 0. 3 plus 12 gives me a 15. So I'm left with 4z equals 15. Alright, and then how do I bring my 4 to the other side? Well, the 4 is secretly multiplying to the z, so the way we bring it over is by dividing it. Which 4 divided by 4 cancels and turns to 1, and I can't really reduce down 15 over 4, so z is going to be a fraction, and that's okay because fractions are our friends. So z equals 15 over 4. Alright, so we have tackled our z value. Bam! So now we need to find JL and KM, which JL and KM have z's in it. So I can just substitute in the z value to help me find the diagonal. And if I do this correctly, you guys, the diagonals should be equal to each other because the diagonals are congruent. Alright, so let's get going. So I'm going to start with my Km, which Km equals 9z minus 12. So Km equals 9 times my z value, which is 15 over 4. So times 15 over 4 minus 12. Alright, which remember you guys, fractions, we go straight across when we multiply, which the 9 is secretly over a 1. So 9 times 15, well, I don't know that off the top of my head, so I'm going to have to do some scratch work. So 15 times 9 will give me 135. And let's see here. Let me double check. 150. Yeah, there we go. So it's 135. So Km equals 135 over the 1 times the 4 will give me 4. And then minus, which I also want this one to be over 4, because remember when you add or subtract fractions, you guys, you must have a common denominator. So I'm going to put my 12 over a 1, and the goal is to get a denominator of 4. So what can I multiply to a 1 to get 4? You do multiply it by 4. You guys are so brilliant. Okay, which remember, if you multiply it to the bottom, you have to multiply it to the top. And we just go straight on across. So negative 12 times 4 gives me a negative 48, or minus 48. And 1 times 4 gives me a 4. And then we simply just combine the numerators and keep the denominator the same. So Km, 135 minus 48, that will give me, let's see here, 5, 8 is 13. I want to say 87. Let's see here. Yes, 87. So this is going to be 87 over 4. Let me double check again. Yes, okay. So Km equals 87 over 4. Yay! So now if I did this correctly, JL should also be 87 over 4. So let's see what happens. Let's solve for J to the L. So JL equals 5z plus 3. So let's get going. So JL equals 5 times my z, which is 15 over 4, plus 3. Alright, which remember with fractions, we just go straight on across. So JL will equal 5 times 15, which is 65. Or no, hold on. 75. Sorry, guys. Jeez. Almost made an error. So let me double check. 15 times 5. Yes. Alright, and then we multiply the 1 and the 4 together. So 1 times 4 is 4. Alright, and then in order to add my 3 to this lovely fraction, I need to have the common denominator, which currently my denominator is a 4. So what can I multiply to a 1 to get a 4? You guys are too cool for school. You would multiply it by 4, which if I multiply it to the bottom, I have to multiply it to the top. And we go straight across. So 3 times 4 gives me a 12. And 1 times 4 gives me 4. So now we just keep the denominator and add the top. So 75 plus 12, it does give me 87, yay! So for JL, we also get 87 over 4. So yay! So KM and JL will equal 87 over 4. Holy hot dog, you guys. We did an epic isosceles trapezoid problem that had a fraction in it, which fractions are our friends. Wasn't that awesome, you guys? I just love problems that have fractions. I hope you guys enjoyed the problem as much as I did, because I had so much fun.